Hi, welcome to the Pythagorean Theorem notes. In this video, I will go over how to fill out your notes for the Pythagorean Theorem. We're going to use a similar format to Cornell notes, where we have information or our main ideas over here on the left and our notes on the right. The first thing we need to know about the Pythagorean Theorem is when do we use it? And we only use it when we talk about triangles that have a right angle. That is the most important part of the Pythagorean Theorem. You can't use it on just any triangle. It has to be a right triangle. So you should have two highlighters. I want you to grab one color, and we'll make ours green here. And I want you to highlight these two sides, sides A and B. Those two sides that actually create our right angle right here, those two sides are called our legs. So over here in this blank, we're going to write the word legs, because that's what they're called. These are our two legs of a right triangle. And I would like for you to please highlight the word legs in the same color. Grab your other highlighter, different color, and I want you to highlight the long side C, that long diagonal side, and this is side C. You're going to learn that side C is the most important side, and it has a nice long mathy name, and it is called the hypotenuse. Hypotenuse. Okay, the hypotenuse, and we're going to highlight that the same color as our side C. So grab that highlighter and highlight the word hypotenuse. So take your pencil, and I want you to boldface this arrow. You see this arrow that's coming off this corner? This is a really important arrow here, because this arrow shows you what side is side C. All of our right triangles don't have to be as neat as this one is. They can turn it upside down, they can make it go backwards, any direction. So we have to know the hypotenuse. We have to know our side C. Our A's and B's are both legs, so those can change. This could be B, that could be A. Those don't really matter. But side C is the most important side. It's also the longest side. So I want you to make a little note down here, please. It says longest side. All right, there we go. And this is the hypotenuse. Now make sure when you draw your arrow from the corner of that right angle, and if you have another color marker, feel free to really highlight that bad boy. Because it is very important. When you make the arrow off of your right angle, it should always point straight across. It should never bend in any direction, just straight across to find the correct hypotenuse. So those are the parts of the right triangle. You have legs that create the right angle, side A and B, and then you have side C, which is the hypotenuse, and that's your longest side. So what is the Pythagorean Theorem? There is a guy back in ancient Greece called Pythagoras, and he created this theorem. He said that if we took two squares and we took another square like this, if we had a third square that was diagonal to it, so it went like this, you guys see that? That the areas of these two squares would fit inside this square. They would add up to the area of the third square. So if you notice, and you can draw this if you want, it's, you don't have to, but if you notice, there's your right angle, and this is the longest side. So if you took the area of this guy and the area of this, so the area of the two smaller squares, and you added them together, you would get the area of the big square. This is very helpful if you want to do any sort of carpentry, engineering, anything where you have to build, right? It's really important to know the Pythagorean theorem. It is used to help us solve for missing lengths. We could solve for the area of a square if we didn't know it, if we knew all the lengths of the right triangle. So the Pythagorean theorem is used to find a missing length on a, what kind of triangle did we say it had to be? Right, it has to be a right triangle. It cannot be any other kinds. Now there are lots of different triangles, but to use the Pythagorean theorem, it has to be the right triangle. So here's the formula. Now, back in my day when I went to school, you had to memorize this. And by the time you're done with this part of the unit, you may actually have it memorized too. Luckily, though, on your formula sheet that you get for all tests and quizzes when it comes to geometry and measurement, including the SOL, you will have this formula on the sheet. So if you forget it or you don't have it memorized, do not stress. So the formula is a squared. So that's a with the exponent of 2 to the power of 2 plus b squared equals c squared. So it's all your sides. You square them. You add your legs together, and then you'll find the area, the entire square of the third side. So we'll have to figure out something if we just want this side piece. So that is the Pythagorean theorem in its whole. Now let's look how we can apply it. You're going to be able to apply this in 3 different ways. So one is proving if 3 numbers create a right triangle. You're going to be able to find the missing side, and then we'll do it a third way with word problems, and that's on the next sheet. So first, let's look at proving right triangles. Given 3 side lengths, use the formula to show whether or not they represent the sides of a right triangle. If they do, we call them the Pythagorean triples. That's our name if all 3 sides make a make a right triangle. So here, I'll do 2 of them for you, and then I'd like for you to try the bottom 2 on your own. First of all, we have to label. We have to know our A, B, and C. Like I said, the A and B don't matter. Normally, I just do it in the order they give it to me. So in this case, A is 8, B is 15, and C is 17. Now, you know how I said it doesn't matter? Well, I kind of was untrue. The A and B don't matter, because if you look at it, A squared plus B squared is on the same side of the equal sign, right? So this doesn't matter. You could make A 15 or B 8, but C has to be the biggest number. Why? Because as we decided up here, C is the longest side, so it has to be the biggest number. So in this case, C would be 12, 25, 18. It has to be the biggest number. I don't care what you make A and B, but C has to be the biggest. So let's keep going. Once we figure out our labels, A equals 8, B equals 15, C equals 17, we're just going to plug them into the formula. So this is going to be 8 squared plus 15 squared equals 17 squared. Okay, that's all I did was I took my A, my B, my C, and I plugged them in. Now let's do some math. 8 squared is 64. B squared is 225. If you don't have these memorized, the squares, that's okay. For example, I'm not 100% sure what 17 squared is, so grab your calculator. On your calculator, above your 8 key, you will see an x squared key. That's what you use to find out a square. Now you also have y to the x, which is above your division key. You can use that. You would type in the number 17, y to the x 2, and equals. The x squared button is like a shortcut. It just does it very quickly without the extra buttons. So I want 17 squared. I click my square button here, 289. So I'm going to come back over here, 289. One last step, I need to add these two together. Grab my calculator again. And let's see, 64 plus 225 equals 289. All right, that's awesome. So what you do is you come over here and you're going to write 289 equals 289. Now if you get the same number, that means this is in fact a Pythagorean triple. 8, 15, and 17 in whatever measurement you use, inches, centimeters, feet, whatever. If you made one side 8, right, one leg is 8, one leg is 15, the hypotenuse, the longest side, that would be 17. And that is a Pythagorean triple, so you give yourself a check. Okay, it seems pretty easy, yes? Let's try number 2. A is going to equal 5. Again, it could be B. Those two don't matter. A and B don't matter what you label them. But C matters. C has to be the biggest number because it's the longest side. So C has to be 12. And we're just going to plug it into our formula. A squared plus B squared equals C squared. 5 squared plus 9 squared equals 12 squared. So 5 squared is 25. 9 squared, 81. And again, you can use your squared button, that's fine. 12 squared, 144. All right, once I have this done, I want to add these two together. Let me get my handy dandy calculator here. Well, that'll work. Clear that out. And now I have 25 plus 81 equals 106. All right, so 106, we're going to write that down below. Now, does 106 really equal 144? Is that the same number? No, it is not. They are not equal. So the numbers 5, 9, and 12, while they could be a number, numbers for any type of triangle, those three numbers in particular would not create a right triangle. They could create some other kind, but not a right triangle. So you put an X. I would like for you to try 3 and 4 on your own. Give yourself a check if it's right, or an X if it's wrong, meaning that you don't get the same numbers. If you need help, ask your teacher, but go ahead and pause this video. When you start it up again, we'll come down here to the missing side. Okay, hope you got 3 and 4 done successfully. Let's look at another way they could ask you to apply the Pythagorean theorem. Finding a missing side. Use the Pythagorean theorem to find the missing side length. Round answers to the nearest tenth. So this is important, rounding to the nearest tenth. Let's go ahead and circle that, because that means we only want one number after the decimal, right? You don't care how many are in front, but the tenth place is that first number afterwards. So that's what we got to round if we have to. Let's look at number 5. So we have a triangle and we have our missing side length. We want to figure out what this side is here. The first thing you do when it's a right triangle is you find your right angle and you draw that very, very important arrow. Because as soon as you draw that arrow, you have discovered side C. Once you have side C, it doesn't matter what you make A or B. So let's go ahead, we'll make 8A, so that'll be our side A, and this will be our side B. The most important side is C. That's why you draw the arrow first and label C first. That is very important. Label C first. Now we have a little bit more room, so I want you to go ahead and rewrite your formula here. A squared plus B squared equals C squared. And now we're going to plug it in. So A is 8. So we have 8 squared. B is 7. And C, we don't know what C is. C is X, right? So we are going to write X squared because we don't know what it is. Now, so the first step is really label your sides, right? Draw your arrow, label your sides, and plug it into the formula. Now we get to do some math. 8 squared is 64. So this is similar to what you just finished doing up top. 7 squared is 49. And we still don't know X, so we're going to put X squared. Add your two sides together. I'm going to get out my calculator here. 64. Wait, let me clear it out. 64 plus 49 equals 113. Excellent. All right, so I'm going to put 113 here. Equals X squared. Now I'm going to stop for a minute. We're not quite done. X squared, so if I were to draw that big square we were talking about earlier, if I were to draw that over here, the area of the square would be 113. But to find just the length, we have to undo the squaring. So you know how adding and subtracting are inverses, right? They're opposites. Multiplying and dividing are also inverses. What is the inverse? What's the opposite of squaring something? You might recognize it on your calculator if you look there. What is the opposite of squaring? In case you don't know, it's the square root. And for you guys, your square root button is going to be above the 9, and it just has the square root of x, and that's above the 9. There are different types of square roots. You could do a cube root, or there are different type of roots, I should say. You have your square root, your cube root. This one means you can make it any sort of root. But for all of the Pythagorean theorem, we are going to be using the square root. So we'll come up here. I'm going to use a different color. You can use the same. It's no big deal. But to undo this square so I can figure out just x, I need to do the square root. It's like a V and a division sign. See, just like that. So the square root undoes the square. And just like in algebra, when we have to do the same thing to both sides, you have to do the square root to both sides. So now I have x by itself, and I'm going to find out the square root of 113. Now 113 is not a perfect square, right? There are not two numbers that multiply to get exactly that. So our answer is going to be an irrational number. So we'd have 113, and we do the square root, and see we get this big long decimal. It never ends, it doesn't repeat, it's irrational. So rather than having to write all this out, if we remember our directions, we want to round to the nearest tenth. So I come over here and I look one spot underneath, and that's 0.6. Look behind it, that's just a 3. You guys remember the rule? 5 and above, give it a shove, 4 and below, let it go, right? So that 3 is not going to do anything. So 10.6 should be my answer for number 5 here. So this is going to be, and we're talking inches. You always want to label your work when it comes to geometry, right? When it comes to measurement, you always want to label. So I'm going to put 10.6 inches. And go ahead and do me a favor. Circle your answers. We got a lot of math, a lot of numbers. It's helpful to circle your answers. So x equals 10.6 inches. And that's an approximation, right? It's not exactly that because we had a big long decimal. It's approximately 10.6. But that's how you use the Pythagorean theorem to solve for a missing side. Let's look at number 6. So what you're going to do, remember, the very first thing, I don't care what the triangle looks like, if it has a right angle, you're going to draw that arrow straight across and label your C. Okay? Now, in number 5, we made the side piece A. I'm going to make the bottom A just so you can see that it works. Either way. Okay? Go ahead and do your A squared plus B squared equals C squared. Now you fill in your numbers. This will be 18 squared plus 15 squared equals, and again, we don't know C, right? It's x, so we're going to write x squared. Now it's time for the math. So really all I did here was label, and then I did the plug part. Now we're doing the chug. We got to figure out 18 squared. So clear this out. 18, then using my squared button, is 324. I'm going to come over here. I'm going to write 324. I know that 15 squared is 225, and I don't know x, so I'm just going to rewrite x squared. You keep simplifying and add these two together. So we have 324 plus 225, and we get 549. So that's what goes at the bottom on this side. All right, so again, we had 549. So we'll write that down here. And that equals x squared. You cannot do the square root step until you have one number equaling x squared. It won't work any other way. So you've got to make sure you have a number equals x squared. Now we can take the opposite, right? To get rid of the square, we find the square root. That leaves us with x. And we can do the square root on this side. And to be honest, I don't know what that is. So we had 549. We'll find the square root, 23.43. Now again, we're going to round to the nearest tenth. So I look at my 4. The 3 doesn't do anything to it, so it stays 23.4. And in this case, we're talking, what is that, feet? So 23.4, we're going to write feet, F-T. And that's our final answer. Okay? Pretty, step by step, pretty simple. So I'm going to clear this out. And let's move on to different ways, because while it's easy to find the hypotenuse, if we have different, like if one of our legs are missing, we're going to have to do things just a little different. Now I'm going to do number 7, but I would like for you to do 8 and 9 on your own. All right, so here we go. I'm going to speed it up just a little bit. We find our right angle, draw our arrow, that tells us C. And if you noticed, we now have a number for C. That's what's different. We're going to make, we can make A, X. Again, A and B don't matter, even if one side's missing. And we'll make B 3. So please go ahead again. You're going to write this a lot, and that's good because that will help you remember it. A squared plus B squared equals C squared. All right, so we have our formula, we have our labels, let's plug it in. Now this time, instead of a number going here, we're going to have a letter. We're going to have x squared. So we have x squared plus 3 squared. And this time C is actually going to have a number. It's going to be 11 squared. Now we do some math. Our x has to stay the same because we don't know what it is. So we have x squared. Oh, sorry guys. There we go. Our x stays x squared. Our 3 squared changes to 9. And our 11 squared changes to 121. Again, if you don't know it, just put it in your calculator. Now we have a little bit of algebra, right? Because we have something on the same side as our x squared. And I told you above, you have to have a number and x squared, right? You can't have something on the same side. So this is why you learned algebra first. You have to get rid of a plus 9 or a positive number. And how do we do that? Well, what's the inverse of adding? Right? There's a whole law, additive inverse. We have to subtract. The opposite of adding is subtracting. So just like we did in our other unit, you have to subtract from both sides. So a positive 9 and a negative 9, those cancel out. And I'm left with x squared on this side. And then 121 minus 9, let's grab our calculator. 121 minus 9 is 112. So we're going to put 112 right here. Okay? Now, again, we don't have x yet. We still need just the side. I don't want to know what this square area is. That's what 112 means. I want to know what this side length is. So we have to do the opposite, the inverse of squaring, and take the square root. And that would cancel it out and leave x. And then if we do it to the left side, we must do it to the right side. So we take the square root of 112. We already had the 112 in, so we just hit the square root button. And we get a big, long, irrational number. We go to our 10th spot and we have a 5, but look what's behind it now, an 8. So if we remember our rhyme, 5 and above, give it a shove, that 5 is going to turn into a 6. You don't change all the numbers, you don't keep all the numbers, you just make the 5 into a 6. So our actual answer is going to be 10.6. So let's go ahead and write that down up here. .6. And what are we dealing with? Centimeters. So we're going to write centimeters. And give that guy a circle. All right. Something that can help you when you're doing these is you must make sure that your legs are always smaller than your hypotenuse, right? We said that side C, the diagonal here, is always going to be the biggest number and the longest leg, or the longest side. So if you're solving for A or B and you get a number that's bigger than your C, bigger than your hypotenuse, you've done some math wrong or you labeled it wrong. Something happened for your legs to be bigger than your hypotenuse. So that's your clue. Wait a second, let me go back and check my math, check my labels. 10.6, it's not small by a whole lot, right? Because this is only 11, but it is smaller. So we know we got that one right. I would like for you to do 8 and 9 by yourself. Go ahead and write down a squared plus b squared equals c squared. Go ahead and write that down. on both options. Remember, your most important first step is to draw that arrow so you can find out what is side C. Then if it is not X, like in this case, X is going to be either A or B, you follow the format here, you subtract to get it by itself. I'd like for you to try these two on your own, so go ahead and pause the video. If you get stuck, need help, please raise your hand and a teacher will help you. All right, finally our last step. This is the third and final way that you could be asked a question where you have to use the Pythagorean theorem. Remember, we have already done the triples, the Pythagorean triples, where they give us three numbers and we decide does it work or not. We have found the missing length if it's a hypotenuse or if it's a leg. We found missing side lengths. So now we're going to work with word problems. The most important thing with word problems is going to be drawing a picture. If they don't give you a picture, this is how you can show work on a test or a worksheet, is to draw a right triangle. It doesn't have to be pretty. It just has to be a right triangle that you can label the sides so that you're able to solve for the missing side. All right, let's look at number 10 here. Find the length of a rectangle that has a diagonal of 25 feet and a width of 15 feet. So first we want to make a rectangle. Okay, doesn't matter how big or small you make it. So we have our rectangle and we have a diagonal. Now it's important that you know the word diagonal. Diagonal means corner to corner. Right? Vertical is up and down, horizontal side to side. The word diagonal means corner to corner. So we're going to draw it from one corner to the other corner. That's your diagonal. Let's go ahead and underline some things. We're looking for the length. We needed to know it was a rectangle, so we drew our rectangle, and we're looking for the length. So there's your X. It has a diagonal of 25 feet, so that means this line that we just drew, that's going to be your 25 feet. So we're going to write a 25 right there. And it has a width of 15 feet. Remember, to be able to use this theorem, you have to know two of the three sides. The cool thing about rectangles, anytime they talk about a TV or, I don't know, a bulletin board, anything that has a rectangle or a square, we know all the corners are right angles, so we can draw our right angle in. Don't draw a right angle unless they tell you or they tell you it's a shape that has one. Don't randomly make up right angles because that can get you screwed up. All right, once we have this, now it's just like all the triangles we had above. You can draw your arrow, and we now know, and I'm going to change colors here, that 25 is side C. We can label our A and our B. Let's make A 15, and X is going to be our B. So we have A squared plus B squared equals C squared. Our A is 15. Our B is X, so we don't know it. That's what we're going to have to find out. And our C is 25, so 25 squared. Now go through. Once we've drawn our picture and labeled it and then had our formula and plugged in our known numbers, the things we know, now we can do some math. 15 squared is 225. X squared we don't know. And I just have this memorized. Feel free to put it in your calculator. 25 squared is 625. Again, we don't have x squared by itself, so we need to get rid of what's on the same side. To get rid of a positive 225, we are going to subtract 225. And you're not going to subtract it over here. You're going to subtract it from the other side. Okay? The positive 225, the negative, they cancel out. Excuse me. And we are left with x squared. Well, let's not make it that big yet because we do have one more step above it. Or below it. There we go. Equals 625 minus 225 is a good old 400. Again, feel free to use your calculators. And one more color just to make it fancy. To get rid of a square, we need the square root. So we're going to do the square root on both sides. That goes away. X equals, and the square root you put in your calculator. I just know that the square root of 400 is 20. And we are talking feet, so FT. And that's your final answer. Okay, so the length of the triangle is 20 feet. Okay, all right, let's look at the next one. A 20-foot ladder is leaned against a wall. If the base of the ladder is 8 feet from the wall, how high up the wall will the ladder reach? Now, I'm going to work with you on drawing the pictures for 11 and 12, but I would like for you to do the math on your own because this is important. I think drawing the pictures and labeling you'll get with time, just practice, but I really want you to start practicing just the math part of the Pythagorean theorem. So we have a ladder and it's leaning against a wall. So here's our ladder and it's leaning. See that? So that, if you can tell, is going to be your hypotenuse. And here's the wall. And then you have the ground. So here's your 20-foot ladder. And so this is important. It's leaning against a wall. And it says the base of the ladder is 8 feet from the wall. So here's my wall. Here's the bottom of the ladder. So your base is 8. Anytime you have a word problem that talks about a wall, a house, any sort of building, could be a tree, could be a flagpole, anytime you're talking about something standing upright against the ground, that is your right angle. Because that's going to be helpful so that we can figure out what our hypotenuse is. So we want to know how high up the wall. So how high up is this ladder going to reach? So this is your X. You need to make sure that you go ahead and mark your arrow. So once we have it labeled from the numbers given, you should be given 2 numbers and then the question tells you what you're looking for. You want to draw your arrow because that will help you label side C. The most important side to label is side C. Then you can go and you can label side A and side B. Again, it doesn't matter which is which. That's totally your choice. We're going to do A squared plus B squared equals C squared, and now I am going to let you figure that one out on your own. You can pause the video and go ahead and solve it now, or you can keep listening, write down the picture for 12, and then solve them both on your own in a minute. I'm going to go ahead and do 12 right now. George rides his bike 9 miles south, then 12 miles east. How far is he from his starting point? Okay, so George rides his bike 9 miles south. So we have George. Hey George, how's it going? Just hanging out on his bike. And he's going south. So you can write this over here. It's important to know, right, your directions. So we have never, eat, what do you guys call it? Soggy waffles. It was shredded wheat when I was growing up. Actually, there was a UVA tutor that said she learned never eat soggy worms or slimy worms. Maybe it was slimy worms. Either way, I thought that was pretty good too. Anything you can help to remember this is fine. So south is a down direction. So from wherever you start, you want to draw an arrow going down or a line going down. So first he went 9 miles south. Then he went 12 miles east, and east is to the right. Yeah, so this is down, and this is to the right. So you don't go back up here. You want to go where you left off. So he goes 9 miles south, and then from there you're going to draw a line to the right for your 12 miles east. And the question is, so important things to underline or highlight would be 12 miles south, or 9 miles south, excuse me, 12 miles east, and then how far is he from his starting point. So if he starts here and he ends up there, they want to know what is that distance. So there's your X. That's what they want to know. Again, going directly south and east, there's your right angle in that corner. Once you know your right angle, I hope by now you know the very first thing you're going to do is draw your arrow, because that helps you label C. And then you have your A and your B. Write down your A squared plus B squared equals C squared and solve. If you need help with any of these problems, have a teacher check the ones that you did on your own. If you need any further explanation, please ask a teacher. We'll be more than happy to explain any of the questions on here or answer any question that you have. Thanks for watching.